So in the first section we did yesterday, we looked at sequences and figuring out a formula to predict like the next term. What we're going to look at in 11.2 is what's called a series. All that a series is when you add up the numbers in a sequence and you tell me what they add up to. So for some sequences, that's easy to do. If you have a sequence that's only 5 numbers long, you can easily add them all up. If you have a sequence that's hundreds of numbers long, it's going to take too long to try to add them all up by hand. So what we want to figure out is a quick way for adding up a lot of numbers. That's what this section is.
Google?
Not quite. So look at this sequence. That's a formula for a sequence, like we would have had yesterday.
Wait, what's the difference between a sequence and a series?
A series is when you add all the numbers
So
up.
a series isn't a bunch of numbers, it's a process?
It's a single number. It's like when you add up all the numbers in a sequence.
That's called a series?
That's called a series.
Okay.
Yep. Yesterday was just a list of
Yeah,
numbers.
what is a use case for having a series?
I'll try to show you.
Why do we want to show this? Are you following our curriculum?
Yes.
It has to.
Yes.
No, this is just what he wants
Why
to
do you
do.
So-
listen to the book all the time?
One example of a series would be if you looked at
Sure, fun.
like medication and you wanted to figure out if somebody took the same amount of medication every day and you wanted to figure out eventually how much medication is in their system, it's a series because you have medication from like Monday in your system, Tuesday, Wednesday, you have to add it all together to get the total medication. But as medication is in your system, it kind of wears off too. So you gotta account for the fact that Monday's medication might only be half in your system by the time you get to Tuesday. So it's a series.
So you're telling me I never want to be a pharmacist?
I'll tell you right now.
I don't know.
Is that why I'm at
12 my shop.
Okay, so let's
No, it's
look at this sequence. Aiden, what number would I plug in for n to get the first term in that sequence?
one.
Yeah, we plug in 1.
What number?
What do we get?
My dad.
Will, what do we get if we plug in 1?
You get
1.
Just in the parentheses. Now we'll square it after.
1.
This guy
1,
needs help.
and then when we square it, we would get still 1. I'm just going to leave it as 1 squared.
It's dropped on my head.
Why would you leave it
You
at
can't do simple now.
You'll see. You're going to see a pattern if I leave it like that. 1 squared. Okay. What would we plug in to get the number in the second position? 2. What's in the parentheses if you plug in a 2? 3.
Massive water bottle.
Oops. Okay, now let's plug in. Will,
Yeah.
I need you to be quiet.
Got it.
Thanks. What do we plug in to get the third term?
3.
3. And what do you get in the parentheses when you plug in 3?
2. 5. Wait.
5.
Okay,
So do people see what the pattern is?
Yes.
It's going to be 1 squared, 3 squared, 5 squared, 7 squared. If I did these out in row 1, 9, 25, you might not have seen the pattern as easily.
I'm really bad at finding patterns.
All right.
Thank you.
Let's do one more. If you plug in 4, what do you get inside the parentheses? 7, and then it's to the second power. Now let's do those out. Get off to the side. What's 1 squared? 1. 3 squared? 9. 5 squared? 25. And 7 squared? 49.
How do you know that? Yeah.
Okay.
They're perfect squares.
I don't know what's perfect square.
So now, you could use your calculator if you need to.
Okay.
Like, I admitted math as a kid.
Yeah, but I didn't understand any of it.
Perfect
Oh,
squares
it's
are
so
easy.
good.
Guys.
I don't know.
Hey guys, I really need you to focus. Okay, thank you.
We struggle with that.
Now I want to look at that notation. S with a lowercase n.
Is S the name of the series?
S means sum. Okay? So let me show you what S sub n means.
Okay.
When you write
Songs.
S sub 1, it means to look at this list and just add up the first one. So it's just the first one.
How do you only add 1?
When you do
Just take the first number.
S sub 2 means to take the first 2 and add them up. S sub 3
Only
means
add
to
the first
take
three?
the first 3 and add them up.
Wait, what is
So
it?
S1 is just the first term?
So S1 is just the first term.
Okay.
Yep. S2 is what you get when you add the first 2 terms.
Yes.
1 squared and 3 squared. S3 is when you add the first 3. 1 squared, 3 squared, and 5 squared. S7 would be when you add the first 7. So this number is telling you how many things you want to add up in that box. Okay.
I have a question.
Yes.
So you can't get a series for an infinite one because it would just be infinite?
We're never going to talk about an infinite series in here. So
Okay.
the answer to that would be it depends.
How would you add up infinite numbers?
Every number.
It depends if the numbers are getting smaller and smaller as you go. You can do it if they get very small.
But it still never ends.
It never ends, but it gets close to something. It-
Like the graph.
it's like an asymptote, yes. It approaches.
But it was still be infinite.
Yeah, but it won't ever hit.
Well, maybe I'll talk about it after, but it's not something you need to know. But it depends. In this kind of problem, no, you could not add up infinitely many because each time they're just getting bigger and bigger. So if you added up infinitely many, it would just get
Yeah.
bigger in this case. Right, so any question on that?
No.
So now let's write some of those down. Right, and let's also do let's do S4 because we have the 4th term. Let's add that in. Okay, what does the first 1 terms add up to?
1.
Just a 1. What do the first 2 terms add up to? 10. How about the first 3 terms?
35.
So that's 35. And the first 4 terms, well, we already have 35 for that. What's 35 plus 49?
84.
84.
Nerd.
Guys, mental math.
Okay.
I don't know how to do
Nerd.
that. You're going to make us look good.
Any questions where we got those numbers from?
No, I don't get from Holly.
So now,
No, Holly. I just did that.
Holy.
now the question is if we look at that list of numbers, we want to be able to figure out a pattern in that list. Because if I said to you, what is S sub 10? What do you get if you add the first 10 numbers? What we don't want to do is have to write out all 10 and then add them up by hand. We want to just figure out what is the pattern. Okay, 1, 10, 35, 84. This one would be a little bit harder to figure out the pattern, but we're going to do some that are easier. Okay.
What's the pattern for this one?
The pattern, well, it's quadratic because we're adding up perfect squares.
What is a perfect square?
A perfect square is like 1, 4, 9, 16, 25. Any number you can take the square root of and you don't get a decimal. Yeah. Since this one is adding up squares, it would be a little bit more complicated than finding the pattern for what we're going to do. But I want to make sure people understand how I got those numbers at least.
Yeah.
Okay. All right. So each one of those things that we just added up, that is called a finite series. Finite means we only added up a certain amount. Like we added up the first 2, the first 3, the first 4. That's as high as we went. What we are not going to look at is an infinite series. Okay, adding up infinitely many things. We're only going to look at adding up a given amount of things. And there's always going to be a formula we can use to do it. Because once you get to like 20 or 30, it's not practical to write out all 30 and try to add them up. You want to find a pattern that'll add them up for you. So let me write down what were those numbers we had again. 1, 10, 35, 84. 1, 10, 35, 84. This, what's in that box? That is a sequence of sums. Because each number in this box represents adding up different things to get to it. Here we added up 2 things to get a 10. To get 35, we added up 3 things. And to get 84, we added up 4 things. So each one of these numbers represents adding things up. And the question would be like, what's the next one? Or the next one, or however far down we want to go. Okay, so any question on why each one of those represents adding up a bunch of numbers? So, writing out a sum can be very long. Like, let's say that I wanted to write out something like this. I want to write out the sum of every number from 1 to 100 going by ones. So I basically want to write this all the way up to 100, but I want to write it all out. Okay, I don't want to use dot, dot, dot. Well, that's going to take a long time. Okay, if we want to write all of that out, adding up every single number from 1 to 100, there's a quicker way to do it. So I'm going to show you a notation we can use that represents adding up every number from 1 to 100, but you don't actually have to write everything down like that. And the notation we use has a capital Greek letter, sigma, and that represents the word sum. So anytime you see this in math, it means get ready to add some stuff up. Okay, there's 3 parts to it. This number on the bottom, on the top, and then there's something on the side. If you're adding up a bunch of things, what's one thing you'd have to know if you wanted to add up a bunch of numbers?
What the numbers are.
Right, you have to know what the numbers are. So that's what this tells you. This is a formula
I don't understand.
that tells you the numbers to add. What kind of formula would it be? Just like we had yesterday.
It looks like a picture.
So that's a formula that's going to tell you the numbers that you want to add up. What else would you have to know?
The order.
The what? Well, the formula is going to tell you that. It's going to give you a giant list of numbers. But this is going to give you infinitely many numbers. We're not adding them all up. So what would you have to know?
Which ones you're adding up?
We have to know which ones we're adding up. So this at the bottom is going to tell us what number we want to start to add up. And the top one is going to tell us where to stop. So we've got a formula that's going to generate the numbers. This is going to tell us the first one to use. That one is the last one to use. So it's a short way of saying add up a bunch of numbers. Okay. Let's look at an example. Position and term. Let's say I had 2 in my first position, and then I had a 4 in the second position, 6, and an 8. I want to keep adding up all of these numbers. Let's say I continue that pattern to the 20th position. And I want to represent adding up all the numbers in the top, all the way out to the 20th position. Okay, first thing we would need to do is write down where we want to start. We want to start with the very first position. And I said we're going to stop when we reach what position?
100.
I didn't say we're going to go that high for this one. I'm going to stop at the, I said 20th. Yeah, 20th position. We're going to start at the first term, and we're going to stop at the 20th. Now, we need a formula here that tells us the numbers to add up.
Is Is it AK?
It's gonna be like that, but we gotta figure out what it is. Anybody see what the formula is to change the position into that? And this is what we did yesterday. I think they see, so there's a pattern that changes this number into that number.
Times 2.
Right.
Yeah.
The pattern is times 2. So that's the formula. So if you were to write, we'll write this whole thing. I guess we can write it out. Let's go through what this means. Take the number 1, plug it in for n. What's 2 times 1?
2.
2. That gives you the very first term. Now we go to the next number. Next number up from 1 is a 2. Plug in a 2. What's 2 times 2? 4. That gives me the next one. If I wasn't getting these numbers here, then that would mean this formula is wrong. Okay. The next one is 3. What's 2 times 3? 6. And then I'd go to 2 times, the next one is 4. What's 2 times 4? 8. And you would keep plugging in numbers for n until you reach which number? What's the highest number you would plug in for n? 20. And the last one is 2 times 20, which is 40. So I didn't write them all down, but that's what this notation means. It means to add up 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14, 16, 18, 20, all the way up to 40. So it's just a short way of writing down how to add up a bunch of things. It doesn't actually give you a quick way to do it. If you want to know the answer, you'd still have to type it all in your calculator and do it. It's just a short way of writing down what you want to do. All right, any question on that one? Let's try another one of those. So the difference between these, go back, between actually writing it out the long way and writing it with the sigma, the top one is called sigma notation. Okay, that's a short way of writing down a sum. The bottom one is called expanded notation. So let's try another one of those. Let's make up a sequence. And I'll give you the first 4 terms. Let's say that this is 5. This one is 7. This one is 9. And this one is 11. I want to add up every number in this pattern up to the 10th position. From the first number to the 10th. I don't have them all written out yet. That's fine. I just want to represent adding them all up. So the first thing you need is a capital sigma. What number did I say is the first one we're going to add? What position are we going to start with? What position are we going to start with? Which one?
The bottom?
Yeah, so we're going to start, I said we're going to add up all the numbers from the first one to the, I think I said 10th one. So if we're going to start with the first one, what would go on the bottom?
K equals 1.
Yeah, that tells you where we're going to start. And we're going to stop with which one?
10.
We're going to stop with the 10th one. And now I need a formula that's going to generate all the numbers I want to add up. Does anybody see what the formula would be? It does go up by 2 each time, so that's thinking of it recursively. We have to think of it explicitly. Something you can do to this number, to change it into a 7. And then something you can do to a 3.
Times 2 plus 3.
Yep, that's the pattern. Times it by 2 and add 3. So that represents adding up every number from the first one to the 10th one. Oh yeah, right here. So this means add up all numbers from the first to the 10th. That's what that means. Add up every number from the first one to the 10th one. It's just a short way of saying it. And that's called sigma notation. Now let's write that out. If I plug in 1 for n, what do I get for my first number? How about Zach? What do I get if I plug in 1 for n?
Let's say 7.
So what's 2 times 1?
2.
2, and then plus 3.
5.
You have 5. Okay, so that's my first one. And does that match up with the first term that they gave me?
Yes.
Where was it? Right there, 5. Yep. Okay. Now let's go to 2. How about, Brett, what if I plug in 2 for n?
7.
I get 7. Does that match up with the term they gave me? Yeah, so then this formula is right. Let's keep going till we get to the 10th one. What if I plug in 3 for n? I get 9. When I plug in a 4? 11. And a 5?
13.
And 6?
15.
And 7?
17.
And the 8?
19.
19. And the 9?
21.
21. And we need one more. When you plug in 10, you get
23.
23. This is called expanding notation. Expanded is when you write out the whole thing. The short way is called sigma notation. Yep, so that's all that sigma notation is. It's a short way of writing down how to add up a bunch of numbers. Any question on that? All right, let's try. Let's try that one. So this one says to expand the sum. So expand means just to write it out. Now, where does this one stop? Well, where does it start? Let's go there.
1.
It starts with the first term, and it ends with the nth. We don't know what the nth is. So what we're going to do is we're just going to do out the first 3 or 4, and then eventually we'll just put a dot, 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 because we don't know how high to go. But we do know the very last thing we're going to plug in is an n. Okay? Just like the very last thing we plugged in the other one was a 10. Okay? This one is an n. All right. So to expand that out, what's the first number they tell us to plug in for k?
1.
1.
So if it says something like this, you just want us to do like the first 3 or...
Yeah, we don't know how high to go, so we'll just do the first 3. Like the other one, it said to stop at 10, so we knew. This one we don't know. Plug in 1. What's 2 times 1?
2.
Plus 3?
5.
So we get 5 squared. You can leave it as 5 squared. You don't have to write 25. Okay, let's do the second one. What are we going to plug in for k to get the second term? 2. What's 2 times 2?
4.
Plus 3?
7.
7 squared. And what are we going to plug in for k to get the third term?
3.
Yeah, we just keep going up by 1. 2 times 3 is 6. 6 plus 3 gives me
9.
9. So at this point, we've we've established the first three. Okay. Now, there could be a bunch more we don't know about.
I have a question. Why do we need the square?
I mean, if you want to write it, you can. Just a little bit more arithmetic you have to do out. You could do it out if you want. And Wyatt, what's the last thing that we're going to plug in for K?
3.
We already plugged in 1, we plugged in 2, we plugged in 3. What's the highest they want me to go?
Is it the 2n?
No, there's no 2n up there in that one.
Or what is it, 2k? I don't know then.
So that's our formula.
Oh.
So this doesn't have anything to do with how high they want us to go. Think about the last one we did. Where was the number that told us where to stop?
At the end. Like, I don't know what the number is.
Anybody help them out? Where's the number that tells us where to stop?
The top.
The top. Right? Stop is at the top. So where do they want us to stop this time? N, whatever n is, we don't know. So you're going to take n and fill it in for k. That's the last one. What would you get if you plug in n for k?
2n plus 3 squared.
2n plus 3 squared. We don't know what that is. But whatever n is, that's where we stop. So this is called expanded notation. The top one, what's that notation called? Sigma, yep. So the top one is sigma notation because it uses the capital Greek letter. That's called sigma. And expanded is when you write it all out. Okay, so just think of it as an abbreviation. That's all that the sigma is. It's an abbreviation for writing down, adding up a lot of stuff. All right, let's try. Right, let's try that try one more of those and let's try it in reverse. So, expand the sum. So I'll tell you where to start. I'm going to tell you where to stop. And I'm going to give you a formula to generate all the terms. How would you get your first term that's telling you to add up?
It's 1.
So how would you get the actual number that's going to go in that box?
Plug 1 in for K.
Plug 1 in for k. Yep. If you plug in 1 for k, what do you get?
5.
3 plus 2 is 5. Okay. How would you get the second number you're going to add up?
Plug in 2.
Yep. Plug in 2. And what do you get if you plug in 2? You're going to get 8. Yep. How about Kyle? How am I going to get the third term I add up?
You have to do that times 3 plus 2.
You got to plug something in first.
3.
Yep, plug in 3. And what do you get if you plug in 3?
11.
Let's see, 3 times 3 is 9, plus 2 is 11. Perfect. Caleb, how are we going to get the fourth term we're adding up?
Plug in 4.
Plug in 4. And what do you get when you plug in 4? 3 times 4 is 12, plus 2. Looks good. How are we going to get the fifth term, Logan?
You times it by 5.
Yep, we're going to plug in 5. And what would you get?
17.
17. Mackenzie, how am I going to get which one are we on? 4, 5, the sixth term.
You'd plug in 6.
You plug in 6.
20.
So 3 times 6 is 18 plus 2. So you can see this is a lot shorter way to write this down. This is the long way to write it. Seventh term. Brett, how are we going to get that one?
23.
Yep, plug in 7. We get 23. And Aiden, how am I going to get my eighth term?
8.
You plug it in for
And what do we plug in for k?
8.
8, and that's going to give me
26.
26. And how do I know to stop there?
Because the top says 8, and
Right.
that's the stopping point.
I've reached the top, which is the stopping point. So now if they actually wanted the answer to that, we just have to take all of that, just add it up. Let's see what we get. So we've got 5 plus 8 plus 11, 14, 17, 20, 23, and 26. So the answer to that would be 124.
So if it says expand the sum, we want the answer, and if it says expand a term, it's just the number.
So if it says expand the sum, technically if you write this, you have expanded it. If it said expand the sum and then add it all up,
Yeah.
that would be the 124.
Okay.
Technically, I guess here I did not say to add it all up. So expanded is just when you write it out the long way, and then I just added it up to show you.
Okay.
Any question on that one? All right, so now let's try it in reverse. Right? In sigma notation. So now I'm going to give you something that's expanded. I want you to put it back the short way. All right. Let's do 7 plus 11 plus 13, 15, 17, 19, 21. So I want you to convert that back to sigma.
The bottom would be k equals 1.
Okay, so we're going to start with a 1. And we're going to stop by plugging what number into a formula?
7.
A 7. So now we have to figure out a formula that when you plug in 1, you get 7. When you plug in 2, you get 11. 3, you get 13, and so on. So what I would do now is put those numbers underneath and see if there's something you can do to 5 to make it into 17. So you might think, oh, well, times it by 3 and then add 2. Well, if you times 6 by 3 and add 2, you're off by 1. So it's going to be a pattern kind of like that, though. Anybody think they see it?
Multiply by 2, add 7.
Multiply by 2 and add 7. So let's see. If you multiply this by 2, you get 10. And then if you add 7, you get 17. 6 times 2 is 12. What's 12 plus 7? 19. If you multiply 7 times 2, you get 14. 14 plus 7 is 21. Yep, that's the pattern. 2n plus 7. And that's how you would convert something that's expanded back into sigma. Yep. All right. Any question on that one? Okay. So now, let's look at something like this. Find the sum. I'm going to give you a lot of numbers to add up. It's not going to be practical to do this one by hand. So we're going to have to find a pattern. I want you to add up 1 plus 2 plus 3 plus 4 plus 5 all the way up to 100. So I want you to add every number from 1 to 100. So when we add those up, because I know kind of trick to do it, it's going to add up to 5,050. Every single number from 1 to 100. Okay, but how did I figure that out so quick? Well, I'm going to look for a pattern. You're adding all those numbers up. Let me write it like this. And then let's do 100, 99, 98, and 97. So you're adding up every number from 1 to 100. Can anybody think of a way you could group those numbers together so you're really adding up multiple copies of the same number? Yeah?
Yeah, like 1 to 99 to 100, and 2 to
You
98.
could add 1 to what number?
99.
What about the 100 though?
Just leave it out because it's already 100.
Okay, so I kind of see what you're thinking of. So you could add 1 to 99, okay. And then what?
2 to 98.
And you could add 2 to 98. So if you add them like that, you kind of found a pattern. 1 plus 99 is how much? 100. And 2 plus 98 is 100. 3 plus 97 is another 100. So you just have to figure out how many pairs of hundreds that you have. I think you'd be left with one extra 50 in the middle though, if you do it that way. You'd have one number that's in the middle you wouldn't be able to pair with anything, which would still work. So that's one way you can think about it. The problem is figuring out a trick like that doesn't always work. So let me show you how you can always add up integers, starting with 1 and going as high as you want. That's the formula that you want to know. That's the formula that will add up every number from 1 as high as you want to go. Let's write some of them out, and then we can test it. What do you get if you add the first number up out of all the numbers in that box? 1. What if you add up the first 2 numbers out of all the numbers in that box? Just the first 2. You get a 3. What if you add the first 3 up? 6. What if you add up the first 4?
10.
10. If you add up the first 5? 15. And let's do one more. Add up the first 6. 21. Our goal is to figure this out. What do you get if you add up the first 100? Let's check our formula and see if it works. What I'm saying is if you want to add up the first 4 and you plug a 4 into this formula, you should get 10. Let's see what happens. What's 4 plus 1? 5. What's 5 times 4? 20. And what's 20 divided by 2? 10. So this formula automatically gave you that number. Let's check it for the first 5. What's 5 plus 1? 6. What's 6 times 5?
30.
And 30 divided by 2?
15.
It's 15. So it gave me that one. Right, let's check one more. See if we plug in 6, if it automatically gives us 21, which is adding up the first 6. What's 6 plus 1?
7.
And then 7 times 6?
42.
And what's 42 divided by 2?
21.
21. So this formula automatically gives you all these numbers without you having to add them all up. So if I wanted to add up the first 100, plug in 100 for n. What's 100 plus 1? 101. Right? Times 100 divided by 2. So it's 100 times 101 divided by 2. Well, we can simplify that a little bit. What's 100 divided by 2? So that's 50 times 101. Whatever that comes out to, that's what the first 100 numbers would add up to, and we don't have to do that out by hand. I think that comes out to 5,050. Now, if you didn't want to start at 1, we'd have to fix it. Okay, but this is a formula that works if you start at 1 and you add up every number as high as you want to go, going by ones.
What happens if you don't want to start at one?
We'd have to adjust the formula a little bit. We could make it work, but we're always going to start with 1. Okay. Let's go back to one we had earlier. Find the sum. Let's say we have this. What's different about this one? They're all squared. So it's not quite the same thing we just did. We're adding up every number from 1 to 100, but they're squared. Okay? So what we want to do is see if we can find a pattern. Let's write out the first few by hand, so that way once we get a pattern, we can check it. And then we want to ultimately figure out this. What do you get if you add up every number from 1 squared, 2 squared, 3 squared, all the way to 100? All right, so look at what's in that box. What do you get if you add up the first number in that box?
1.
That's just 1. What if you add up the first 2 numbers? So that's 5. And then the first 3 numbers? So that gives you 14. And then to get the first 4 numbers, you're going to add 16 onto 14. So that will give you 30. And to get the first 5 numbers, you're going to add 25 onto what you already had. 55. And if that's all you have to do, that's not that bad. You can do it by hand. But I want to know the first 100. So let's look at what the pattern is. Okay, so this is the pattern. N times n plus 1 times 2n plus 1 divided by 6. That's the formula you want to know. Okay, how would you figure that formula out? That's a little more complicated. So we're not really working on how do you figure it out. I just want you to use it. Okay. So let's try adding up the first 3. So we should be able to plug a 3 in, and if it comes out to 14, we know it works. Okay. What if you plug a 3 into the first parenthesis? What do you get? 3. If you plug it into the second one?
4.
4. And if you plug it into the third one?
7.
7 divided by 6. Okay. We can reduce that. 3 goes into 6 how many times? Twice. And 3 goes into itself? Once. What's 1 times 4? 4. Times, what's, times 7. 4 times 7 is 28. And what's 28 divided by 2? 14. So that formula automatically added up the first 3. 1 squared plus 2 squared plus 3 squared. Let's check it for the first 4. All right, let's try it again. If you plug in 4 for the first parenthesis, what do you get?
4.
4. To the second parenthesis? 5. And if you plug in 4 to the third parenthesis?
9.
9. So remember, the goal is to see, does this come out to 30? If it does, then we know this works. Let's reduce it. How many times does, let's just do 6 into 9, reduced by 3. How many times does 3 go into 6? Twice. And how many times does 3 go into 9? 3. Okay. What's 4 times 5? 20. What's 20 times 3? 60. And what's 60 divided by 2? 30. So this formula automatically adds up the first n perfect squares. That's what this formula does. Okay. So now, let's add up the first 100. But we're not going to add up 1 squared plus 2 squared plus 3 squared by hand. Okay, let's use the formula. If I want to add up the first 100, what am I going to replace n with? 100. So what we're looking at is this whole lesson is just about a quick way to add things up without doing it by hand. Okay, so we got 100. What if you plug in 100 for the second one? 101.
And then 201.
And then that's going to be 201. And we're going to divide by 6. And if you ever get a decimal, then something's wrong. Okay, these never come out to decimals. So if you add up every number from 1 squared plus 2 squared plus 3 squared all the way to 100, you get 100 times 101 times 201 divided by 6. So 338,350. Way faster than trying to do it by hand. Not only is it faster, what else could happen if you try adding up all 100 of these numbers by hand?
A mistake and it messes up the whole thing.
Yeah, if you make one mistake, like if you do 4 squared and you write 15 instead of 16, then the whole thing is wrong. All right. All right, so any question on that formula or that formula? All right, so main things we looked at is how can you take something that's in sigma notation and expand it? How can you take something that's expanded, change it back to sigma? And how can you quickly add up a bunch of numbers starting at 1 that are not squared, or a bunch of numbers starting at 1 that are squared? And there's tons of other formulas. If you want to do like cubed, 1 cubed plus 2 cubed, 3 cubed, there's a formula for that too. Formula for everything. Any questions on that? All right, so let me put up. Okay, so that's the homework. It's 1 through 3, 21 and 25 in the book. Convert, we'll call this problem A. Convert that to sigma. Problem B, add up every number from 1 to 500, okay, going by ones. And problem C, add up every number from 1 to 200, squaring each number as you go.